Um, Upper and lower bounds are simple to work out if it's just a raw measurement. So if it's 23 to the nearest whole, the lower bound is 22.5 and the upper bound is 23.5. In other words, these two numbers express the fact that that could have been rounded, and these are the boundaries between all the things it could have been and the things that it couldn't. So you can think of the word bound as being short for boundaries. Any number less than 22.5 would not get rounded to 23 as the nearest whole. It would get rounded to 22 or 21 or whatever. And any number 23.5 or above would not get rounded to 23. It would get rounded to 24 or 25, etc. So that's why 23.5 is the upper boundary. Now that is the simple type of question. The harder type of question, which is not that hard, you just need to follow a certain discipline if you're setting out, is when they ask you for the bounds on something that has come not raw and not from measurement but from a calculation. So if I tell you that this is a rectangle and that's 30 to one significant figure, and that's 20 to one significant figure, then what are the upper and lower bounds for the area? Okay. Now, what you do is this. You write the basic calculation. Now, you really got to pretend you're back in primary school. You write 20 times 30 equals 600. Okay? For the upper bound, you replace the ingredients of the calculation with what their upper bounds are. And then you work that out, lining it up vertically with what's above it. So 25 times 35, it's 875. And then for the lower bound, you replace each of those ingredients with their own lower bounds. So 15 times 25 is 375. And they are the upper and lower bounds. Okay? This expresses the fact that your basic answer, of course, is 600 for the area, but for all you know, it could be anything up to 875, because you don't know that that 30 was actually a 30. It might have been 34. And you don't know that that 20 was actually a 20. It might have been 23. So you could have had 23 times 34. And what this does is it says that the worst that can happen is that it was 875 instead of the 600 that you thought it would be. Equally, this says you thought it was a 20. It might have been 15 rounded up. You thought it was 30. It might have been 25 rounded up. So you think it's 600, but in fact, it could have been 375. Not lower, but 375. So again, these express the boundaries between what is too big for it to be and what it is, or what it could be, and what's too small for it to be, and what it actually is. Same with perimeter. If it was perimeter, I'd go 20 plus 20 plus 30 plus 30 equals 100. So that's the basic. Then for the upper bound, I go 25 plus 25 plus 35 plus 35 equals 120. For the lower bound, I'd go 15 plus 15 plus 25 plus 25 equals 80. And so that's your lower bound. Now, please don't feel insulted about me telling you to write this basic calculation out there. It's simply a stimulus to setting it out perfectly. Do not do upper and lower bounds directly on this. Instead, take a step back, write the ingredients, do upper and lower bounds on them, and then whatever calculation you did for the basic, do it for these, and they'll be your two answers. Okay? Now there's a subtlety to do with this, which examiners love testing you out, which is that if it was a subtraction, so if from there to there is 30 to the nearest whole, and from there to there, so that's 30, and from there to there is 80 to the nearest whole, then let's call this PQ. The distance PQ, okay, is 80 minus 30 equals 50. Seems ridiculous to write something as simple as that out, but it's a cue to what you now do. Okay? Now, the worst that could happen, you think it's 50, but the worst that can happen is that 80 was actually an 80.5, or a little bit less than 80.5. And the worst that can also happen is that was not a 30, but instead a 29.5, because then you'd actually have got 51. So this is an example where one gets boosted and one gets lowered in order to do the upper bound. The lower bound, the worst that can happen, is that this 80 wasn't really an 80. Maybe it was a 79.5 rounded up. And maybe this was not a 30, but rather a 30.49 or something rounded down. And so that would give you 49. And so that's your upper bound, and that's your lower bound. The same little trick applies to a fraction. When I say trick, I mean the trick of having to do switchy switch on the boosting and the lowering. See how this got boosted, but this got lowered? And when I lowered this, I, right next to it, wrote the boosting of that. Same with a fraction. If we had seemingly 40 over 20 as the basic, but that 40 was rounded to one significant figure, then the upper bound would be, that 40 could have been a 44.9, and that 20 could have been a 15. And so what you think is a 2 could in fact be anything up to a 3. The lower bound, you think it's a 40, but in fact it might have been a 35 rounded up, and you think that it's a 20, but it could have been a 24.9999 rounded down. So you thought it was a 2, but in fact it could be anything from 3 down to whatever that is. So 1.4, I think. So this is another example of how you have to do a switchy switch. See how I boosted one but lowered the other? And in this case I lowered one and then boosted the other. That's what you have to do for subtraction and division. There's switchy switch. And addition and multiplication, not switchy switch. Reasoning from that, like if there was a powering question, I think that would not be switchy switch, because powering is just repeated multiplication, etc., etc.